This video is going to talk a little bit about atomic structure and some of the particles associated with atoms, specifically protons, neutrons, electrons, as well as information about their location, their mass, as well as their charge. So a quick review an atom. An atom is the smallest part of an element that still has the same properties. So for example, when we did the cutting foil experiment, the smallest amount of foil you can have that's still foil would be 1 atom of aluminum. So if you take a lump of coal, same thing, break it smaller and smaller and smaller. The smallest amount of carbon you could possibly have is 1 atom of carbon. So that being said, there are 2 main parts to an atom. There's the nucleus, the center part, composed of protons and neutrons, and then the outer part is called the Electron Cloud, which of course is composed of electrons. And again, a lot of empty space. So the nucleus is the core of the atom. It contains 2 subatomic particles. It contains protons, which we represent as P+. Why do we represent them with P+? Because they have a positive charge. And we have neutrons, which do not have a charge. They are neutral or no charge. So overall, the nucleus has a positive charge because of those protons. So a little bit about protons. Again, they do have a positive charge. What you can remember that is proton, positive, they both start with P. The mass is 1 AMU. So they do have mass. We count that toward the atomic mass as listed on the periodic table. And the location of the protons is in the nucleus. Oh, let me back up. It says at the very bottom, every atom of the same element has the same number of protons. So for example, all carbon atoms have 6 protons. All hydrogen atoms have 1 proton. That's pretty much what defines that element. So on the periodic table, everything is in order of atomic numbers. So really what it's saying is everything is in order on the periodic table in terms of the number of protons that it has, because the number of protons and atomic number are the same, always. So how do we know the number of protons there are in an atom? You use your periodic table, boom, there it is. For iron, 26, the atomic number. So oxygen, nickel, hydrogen, you can look those up on your periodic table. You can also work in reverse. An element that has 2 protons in its nucleus would be atomic number 2. Which if you look on your periodic table will be helium. You can look the other 2 up at your leisure. Do any elements have the same number of protons? Why or why not? You should be able to answer that question. The short answer is no. If they have the same number of protons, they have to be the same element. Looking at neutrons. Neutrons are the same as protons with 1 key exception. They're neutral, they have no charge. Protons are positive. They're located in the nucleus and they have a mass of 1. Neutrons are not positive, they're neutral. Mass of 1, location nucleus. So as a general rule, all of the mass of an atom is located in the nucleus. So how do you know how many neutrons there are? Typically we've done 8 men in this class. There is a tutorial on Bohr models that shows you how to calculate the number of neutrons using 8 man. But in short, it's atomic mass minus number of protons gives you the number of neutrons. That's kind of a backwards way of thinking about it, because if you think about it, protons plus neutrons gives you atomic mass. So mass minus protons, or atomic number, gives you number of neutrons. So for example, if we use iron, Fe, its atomic mass is 55.8. That rounds to 56, and here's whole number. Take 56, we subtract 26 protons, and that gives us 30 neutrons. Let's talk a little bit about the electron cloud. So the electron cloud has mostly empty space. You have to imagine that there's these almost just infinitely small things flying around here, but while they're flying around, I mean, there's nothing. It's just mostly empty space. It's never really known exactly where electrons are, so they can really be anywhere here at any given time. The thing about it is we represent them on Bohr models as knowing their location as being on a ring. And And that's not entirely accurate, but for the sake of what we do in 8th grade science, you need to understand how that is and how that works. So the electrons are very different from protons and neutrons in every aspect. They have a negative charge. They have a mass of basically 0. And we don't count electrons toward the mass in this class. And location is in the outer part of the atom, the nucleus. So quick review, protons and neutrons in the nucleus both have a mass of 1. Electrons in the cloud does not have a mass of 0. How can you determine the number of electrons? Well, if you have, let's say, a certain number of positive charges, you have to have an equal amount of negative charge in order to offset the charge. So all atoms, as a general rule in this class, are a charge of 0. So for example, oxygen has 8 protons. So if it has 8 positive charges, then it has to have 8 negative charges to equal 0. So it has 8 electrons. And 8-man, we exercise that because the A, atomic number, is always the same as the number of protons and the number of electrons. Electron clouds are areas within the nucleus where there's a high probability of finding electrons. Orbitals are areas within the electron cloud that have a higher probability of finding electrons. So specifically, those are the rings that we draw on Bohr models. So here's an example showing you orbital letters in the nucleus, the center. We've got our first orbital holds exactly 2 electrons. That's its mass. The second orbital can hold 8 electrons, and the third orbital can hold 8 electrons. And again, you fill the shells closest to the nucleus first. So this first shell has to fill up before you add once to this one, and that one fills up before you add once to this one. So just if you wanted to practice this, you could do Bohr models for hydrogen, oxygen, fluorine, sodium, aluminum, and argon. That would be good practice. This just shows you that with each atom, as you work your way across and down the periodic table, starting with atomic number 1, shows you how the electrons are configured. So the first element in the periodic table, hydrogen, has atomic number 1, that means 1 proton, that also means 1 electron. There's your 1 electron in that first orbital. Helium is the second one. It has an atomic number of 2 electrons in the first orbital. Remember that 2 is the maximum amount of electrons that shell can hold. So that means that the next electron has to go in the second shell. This would be lithium. It has 3 electrons. 2 in the first shell, 1 in the second shell. And as we work our way down, we start adding electrons to the second shell. That's 4 valence electrons, 5, 6, 7, 8 valence electrons. 8 is full. So when we get to the next one, which is an alkali metal, sodium has 1 valence electron in its third shell. Magnesium, 2, 3, 4, 5, 6, 7, and 8 with argon. Again, we're full. This is a noble gas. Quick reminder about reactivity. Noble gases, when the outer shell is full, when the valence is full, that is a non-reactive element. Non-reactive. Will not react. It's stable. Argon will never bind with some other element. On the other hand, the less electrons you have in that shell, all the way back to sodium, which was an alkali metal, 1 valence electron. This is an extremely reactive element. So less valence electrons, as a general rule, we say more reactive. That's all for atomic structure and reactivity today. I hope that this was helpful if you had some confusion about protons, neutrons, and electrons in atomic structure. Please be sure to check out the video on Bohr models if you're still struggling with that. Thanks.